Hey guys, Mr. Mises here, and I'd like to talk to you about type 1 and type 2 error and power. Um, I'd also like to talk to you a little bit about alpha level and kind of seeing what the connection between alpha level, power, and sample size has to do with type 1 and type 2 error. So here is a chart, and this is basically a chart that you can find a lot of these online about rejecting the null or failing to reject the null and what's actually occurring in reality. So we've already discussed in a previous video that a type 1 error happens when we reject the null hypothesis when it actually is true. And the probability, we talked a little bit about this in class, the probability of getting a type 1 error is going to be alpha. So alpha actually is the probability of getting a type 1 error. And that alpha level is picked before the hypothesis test is done. Type 2 error is when we fail to reject the null hypothesis and the null hypothesis is actually false. So when we have that type of error, the probability of getting a type 2 error is called beta. Now beta is not alpha, we just kind of come up with. We define that before we do our hypothesis test, but beta is calculated using we need other things to calculate beta. So we need sample size, we need to know standard deviation, we need to know some other things in order to calculate beta. However, 1 minus beta, the probability of actually getting it right, of correctly rejecting the null hypothesis when it's false, is really what we want to do, right? If we're creating an alternative hypothesis and we want to provide evidence of that alternative hypothesis, then our goal really is to reject the null hypothesis, and our goal should be to reject the null when in fact it is false. So this is probably our ideal condition here. And so if this happens, the probability that our test can do that is called the power of the test. So the more power your test has, it's the more likely, the higher the probability that we're going to reject the null when the null is in fact false. So let's take a look at the connection between power, the probability of correctly rejecting a false null hypothesis, and alpha, and what happens with the sample size. So I want to take a look at a few questions here. We want to talk about how does an effect size change the power of the test. Now, very briefly, the effect size is basically what effect do the two variables have on one another. So a hypothesis test, it will tell us if our results were significant, but it won't tell us the effect of that significance. Effect size tells us that effect size basically tells us what effect that significance has on the real situation. We'll look at that, but it's really not a huge thing for us in AP statistics at this point. What happens when type 1 and type 2 errors increase when we increase the sample size? What happens to our type 1 and type 2 error? The other question we want to answer here is what happens to our type 2 error as our type 1 error decreases? And in general, what can we do to decrease each type of error? All right, so what I'm going to do here is I'm going to look at another website here. And here's another website that has kind of a neat scale thing that we could do. So what I'm going to do is I'm going to solve for the power. And so in red, this is our distribution, our normal distribution of the null hypothesis. This is the null distribution. And this right here, this is our alternative distribution. The part that's in blue is going to be our power. This is our probability that we correctly reject the null hypothesis when it is false. Our red part right here is our alpha, or our rejection region. And I'm going to go and set that to 0.05. What happens when I set to 0.05? Okay, and our just real quick, our effect size here is 0.46. It's the difference between the null and the alternative hypothesis. Now, what I want you to look at is I want you to look at what happens to my power when I increase my sample size. Okay, so right now I have 64% power. So when I increase my sample size to 26, what happened to my power? It also increased. To 30, my power increased as well. To 39, my power increased as well. 43, it got better. So as my sample size increased, the power of my test also increases. And hopefully, I mean, this should make kind of sense. The more people we have in our sample, the more likely we're going to correctly reject a false null hypothesis. Smaller sample has much more variability in it, and we have less power in our test. Notice that as power goes up, as the probability of our power goes up, the probability of our type 2 error goes down. That should make sense because one is the opposite of the other, right? They're inverses. Let me go and solve for alpha now. Let's see the connection between alpha and power. If I decrease my power, now if I decrease my power, I should be increasing my type 2 error, right? If I increase my type 2 error, what happens to my type 1 error? Increasing my type 2 error decreases my type 1 error, right? Decreasing my type 2 error increases my type 1 error. Either way, we're going to have a probability of getting an error. If we lower our alpha level, okay, remember this is alpha level. Type 1 error, the probability of getting a type 1 error is alpha level. If we lower our alpha level, first let me start really high. If we lower our alpha level, our type 2 error goes up. Our type 2 error goes up, right? Lower alpha level, type 2 error goes up. Sample size. What does sample size do to n? Let's see. Type 1 error. The smaller the sample size, the greater the type 1 error. The larger the sample size, the smaller the type. So wait a minute. What we just looked at in this example here is that when sample size increases, it not only decreases type 1 error, but it also decreases type 2 error. We want to, okay, we're going to put these at the same right here. I know that looks weird. Hold on. Oh, we can't do it at the same. All right, watch this. Okay, we've got power. Increase the power, sample size goes up. Decrease type 1 error, sample size goes up. So as sample size increases, we can actually decrease both the type 1 error and the type 2 error. How do we decrease both types of error? How do we decrease the probability that we get a type 1 error and a type 2 error or a type 2 error? Then what we do is we increase the sample size. All right, so let's go back and answer some of these questions that we just talked about. How does effect size affect power? Well, we didn't actually answer that one. Let's go back to answer that one here. Increase the effect size, increases the power. Decrease the effect size, decreases the power. So, how does effect size affect the power of the test? As we increase the effect size, it increases the power of the test. What happens to type 1 and type 2 errors when you increase the sample size? They both decrease. Type 1 and type 2 errors decrease when you increase sample size. What happens to type 2 error as type 1 error decreases? Well, as type 1 error decreases, type 2 error increases. As type 2 error increases, type 1 error decreases. As type 2 error decreases, type 1 error increases. They're basically inverses, guys. I know I said decreases and increases a lot, and you're probably like, oh, what's he talking about? As one goes up, the other goes down. In general, what can we do to decrease each type of error? We just found out you increase the sample size. That'll allow you to decrease both types of error. All right, remember, guys, that the power of a test is the probability that you do not get a type 2 error. Okay? You do not get a type 2 error. So if you increase the sample size, you're going to increase your power because you're decreasing your type 2 error. All right, so that's it for this video on type 1 error, type 2 error, power, effect size, and sample size. We'll talk to you soon.